All right, we have our infrastructure set up. We chose to use routing protocol RIP, but we do have our static routes. And what I'm going to do is I'm going to open up router 1, and let's move it over here. We'll set up our little window so we can take a look at what we have. Let's get rid of this gibberish. Show, start. And what we can see is we have our interfaces all complete. Here's our RIP. As you can see, it has the classful boundaries for each class of address, but we also have the static routes. And that's one thing we need to talk about. We need to talk about, 1, the process of routing, and 2, the dynamic routing process or the static routes. Which one should we use? So let's talk about that. While we can keep this up here, it's not a big deal. What happens in the routing process is the following. When PC1 wants to send, let's say, PC2 a ping, we all know that's an ICMP request and reply. When it's the very first time, what happens is PC1 sends an ARP request to the gateway of router 1, which is the F00. Router 1 then replies, hey, here you go. This is my MAC address. Once PC1 receives that, it completes the frame and then sends it to the router. When the router 1 that is, I'm going to minimize this just to get it out of the way. When router 1 receives that particular information, that frame, it actually discards any layer 2 information because ARP is local to your segment. So it takes a look at the layer 3 information, looks at its routing table and says, hey, where do I need to send this destination? It sees that it needs to send it out the S000 based on the routing table. Once it gets to the other router, that router does the same thing. It takes a look at its routing table based on the layer 3 information, sees that it has to go out the F00. Now we're talking about Ethernet, and ARP only happens on Ethernet. So it must know the MAC address of PC2. Sends the ARP request down to PC2. PC2 says, hey, that's me, out of all the 200 or 2,000 IP addresses or computers that are there, and says, okay, here's my MAC address, default gateway, router. And when it completes that frame, then it can send down the frame to PC2 where it completes the first part of the ICMP request, and then the process repeats itself on the way back. So you can see it's a large process. We take for granted when we ping that things should happen right away. But look at everything that needs to happen to get from point A to point B in a simple ping. It's one way to get the ARPs, and then the other way, the same process. So it is a process. So not only do we need to understand that that is going on, but we chose RIP. Why did we choose RIP? Well, it's a dynamic routing protocol, makes the life of the administrator a lot easier. All you need to do is tell your neighbor router, hey, this is who I'm connected to. This is called routing by rumor. So we're only connected to these 2 particular networks. If you were to choose static, which we did earlier, it's manually. You got to actually create the routing table one by one, telling the router, hey, these networks exist beyond a certain point, which is very cumbersome for the administrator in a very large network. So definitely dynamic routing is the way to go. But we chose RIP. Why not EIGRP? These are Cisco routers. They're proprietary to Cisco. We could have used EIGRP, but it's not a large enough network. Not a large enough network to use EIGRP. EIGRP, 100 to 250 routers. That's its limit right there. So medium-sized to large networks. Why not OSPF? Well, OSPF is for very large enterprise networks. Thousands of routers, hundreds and thousands of routers. But OSPF, good thing, is multi-vendor. Bad thing, if you want to consider it a bad thing, that is very processor intensive. That would be the only thing. We actually chose to use RIP version 2, and for this network, that works perfectly. So now that we have RIP running on our network, now it's time to make sure that all our configurations are correct.